Part 2 conference call. At this time, all participants are in a listen-only mode. Later, we will conduct a question and answer session and instructions will be given at that time. If you should require assistance during the call, please press star, then 0. I would now like to turn the conference over to your host, Jason Dietz from Federal Highway Resource Center. Please go ahead.
Thank you, Jen. Welcome, everybody, and thank you for joining us today. My name is Jason Dietz, and I'm with the Federal Highway Resource Center, and we're partnering today with the Pavement Preservation and Recycling Alliance, PPRA, on a series of pavement preservation webinars focusing on pavement preservation. Today's webinar will focus on how to construct high-quality slurry and microsurfacing treatments, Part 2. You will see a number of polls up on your screen. We ask you to take a moment to answer those as we get close to closing them as the presentation begins. We also encourage questions during the webinar and ask you to please take the time to respond to the evaluations at the end of the webinar. All attendees are on mute, but you can submit your questions through the chat function on your screen, and we will answer those as time permits. We also will be offering PDHs for today's webinar upon request, so please let us know after the webinar if you would like to receive them. This month's webinar is hosted by the International Slurry Surfacing Association, ISSA, and now I'd like to introduce today's speaker, Tim Harwood, the manager of the Southern Contracting Division for Vance Brothers, Incorporated. His area of operation includes Alabama, Louisiana, Mississippi, Tennessee, Arkansas, and Oklahoma. He started in the slurry seal and microsurface industry 32 years ago in Little Rock, Arkansas. Tim has participated in the placement of slurry seal and microsurfacing in multiple states along with several Central American countries. He has served on the ISSA Airport and Specification Committees and chaired the Slurry Systems Workshop for 7 years. Tim served on the ISSA Board of Directors for 8 years and served as the president of the International Slurry Seal Association in 2010. In addition, he served on the chairman of the ISA Technical Marketing Webinar and Web-Based Training Committee, which produced the 3 base web training modules through the cooperative agreement with the Federal Highway Administration and ISSA. He currently serves as vice president of the Foundation of Pavement Preservation, FP2, and sits on a committee that helps design and implement the current preservation group study at the National Center of Asphalt Paving Technology at Auburn University. Tim, on behalf of PPRA and Federal Highway, I want to thank you for your time today, and now I'd like to go ahead and pass it over to you.
Thank you, Jason, for that nice introduction. And if we can go ahead and pull up the first slide, we'll get going. And I want to take this time to thank everybody for taking the time out of their busy schedules to attend this webinar that Jason and FHWA graciously are putting on. Please don't hesitate to put your questions in the chat box, and we should have some time at the end of the presentation to answer some of those questions. So this is part 2 of how to construct high-quality slurry and microsurfacing treatments. And the agenda today, or the topics discussed in part 2 today, were kind of brought up in the question session of the part 1 webinar, which is viewable and recorded. And a lot of folks asked about calibration, and with that, test strips follow up, and then troubleshooting special situations, and then we'll go over secrets to success at the very end. So we're kind of cherry pick and go through it in that fashion. And let's see. Not letting me forward this thing. There it goes. Every good presentation starts with a disclaimer. Of course, it's not intended to recommend that this training be used as a verbatim specification. It will include a lot of best practices that come directly from ISSA literature. And more than anything, it should be used as a guide to assist contractors and agencies put together and, a program where you can construct a high-quality project. Okay, the source document for today's information is the newly updated ISSA Design and Inspection Manual, which digital copies are available to current members now, and the digital or hard copies for non-members will become available January 1st of next year. So right around the corner for non-members. But a lot of great information, a lot of years worth of effort went into updating this and adding all the design language to the already inspection language that was there. So it's a great document. Go out and get it, and it's very reasonably priced to members, which is free. Let's start with our project or presentation assumptions. We're going to start from a point where we know that the proper site selection is in place when the job was designed. We know that the project's been bid. We know it's been awarded. We know that a complete and thorough mix design has been submitted and approved by the agency, and that the pre-construction meeting has been held. Materials have been delivered to the job site. They've been tested, and they've been approved for use. So what are we looking at from that point on? I just put together just a little tentative sequence of activities that you might see at the beginning of a project from that point forward. And the first thing you're going to see is the agency and the contractor completed training available covering slurry seal and microsurfacing. And I put the link to where you can find that web-based training. As far as slurry and micro goes, I think there's a little over 6 hours worth of that training that's offered free from FHWA and ISSA. It's great information for just-in-time training, and it's really designed to help those with limited familiarity with the treatments become familiar with those treatments before they have to perform oversight, or from the contracting side before they have to place the treatment themselves. The agency of the contractor have communicated about a timeline for the project startup and talked about schedules, which is the next bullet point. Those schedules have been submitted and agreed to, which when that happens, we got to know that the agency has completed or put forth some kind of effort to complete the first phase of public notification, if applicable. We talked about that extensively in part one. It's great to have a three-pronged approach to notifying those that are going to be affected by this project. The more informed the traveling public is, the better off everybody is as a direct result. And after that, then the contractor mobilizes to the project. What do we do next? Well, contractor sets up the staging areas, screening plants, emulsion tanks, and all the auxiliary equipment, and does general organization. Okay? While they're doing that, they'll have a crew out starting phase 2 of public notification, if applicable, obviously. The contractor will start his final surface preparation operations on the pavement to be treated. So all the preliminary, or the first phase of that surface preparation has already taken place. Any patching, crack sealing, curb repairs, things of that nature is well behind us, and now we're just doing final sweeping, cleaning, maybe a little herbicide removal, things of that nature. Then one of the most important things that the contractor is going to do prior to starting up the job is he calibrates the application equipment in the presence of the agency representative. And it's extremely important that the agency participate in the oversight of this calibration. Not only does it give them some familiarity with the equipment and how the materials or how the component materials are blended together in the proportions that are necessary, it just lets them know how the equipment works. It's not something that they typically see, and in about 2 hours worth of time watching a calibration, they can learn an enormous amount of information that will make them more comfortable with the operation. Upon completion of the calibration, the contractor sets up the machine to produce that mix that matches the job mix formula, which we'll talk about here in just a minute. Okay, the contractor then is going to go out and perform a test strip, which should be part of the project and in similar project conditions. We'll talk a little bit more about that as we get farther into the presentation. And then the agency and the contractor evaluate that test strip after it's put into place. Okay? If acceptable, the contractor proceeds with treatment installation and major project production. Okay. We talked about calibration and how important it is, and I really cannot emphasize it enough of how important the calibration is. If we've taken all of the necessary steps to evaluate all of the component materials individually and when mixed in a lab, if we put them through all the rigors of the performance training to determine the job mix formula, the proportions that we need to mix it in to provide us the best performance possible, if we do not produce a mix that is a mirror image of that job mix formula out in the field, then we kind of leave ourselves a little vulnerable. We don't want to really be doing any stunt paving or making harsh decisions. We want to stay within that job mix formula. And there's a little bit of, for lack of a better term, a little bit of wiggle room within that, within those optimum ranges, depending upon the actual project that you're working on. But it's important, again, that the agency get involved with the oversight of this calibration process. I've seen many times where agencies kind of sit across the stockpile and they look up and they say, yeah, the contractor's calibrating. Well, they just don't gain as much information as they could potentially be gaining if they were over there watching the weights and seeing how the materials come through the machine and things of that nature. So please get involved. Contractors typically welcome that oversight. And again, not only will it familiarize you with the equipment itself, but it will help substantiate to you that the contractor is going to be producing a mix that is outlined in the approved mix design. Now, the statement that you see on this slide here has got some bold letters that are underlined, and that's kind of more of a recent change that ISSA has adopted in that design and inspection manual. It says it is essential that calibration be completed using the actual job materials immediately prior to each job startup and in the presence of the buyer's authorized representative. Now, in years past, ISSA kind of recommended or condoned the transfer of calibrations from job to job, and some specifications even allowed calibrations that were done in the same calendar year. They indicated that they could be transferred. Some were 6 months. It's not a terribly lengthy process, and ISSA feels, as do I, that calibrating more often is better than calibrating less often. And doing it in front of every agency that you work for, again, gives them that opportunity to gain familiarity with the way these treatments or with the way these components come together. And it kind of gives everybody a nice feeling going into the actual project that things are as they should be, rather than speculating off of an old calibration that has been submitted. Okay. Calibration recommendations further state that each mixing unit to be used in the performance of work shall be calibrated in the presence of that agency representative. So if you see the picture here, if they're using truck-mounted units and they've got 3 of them on the project, then they need to calibrate all 3 of those machines to make sure that they're producing the same exact mix. If you're using one continuous machine, then you've only got 1 to calibrate. Now, the documentation shall include an individual calibration of each material at various settings, which can be related to the machine's metering devices. Any equipment replacement affecting material proportioning requires that the machine be recalibrated. Some examples of that, and it doesn't happen very often, if you have an emulsion pump go out, or if you have a conveyor belt lock up, or the belting tears and you have to replace it, or the skirt board rubber on the conveyor, that may be a good reason that you need to go back in and recalibrate that particular component material. So no machine will be allowed to work on the project until the calibration has been accepted. ISSA Design Inspector's Manual describes a method of machine calibration, which you can find in the appendices of the manual that I mentioned earlier. Blank forms, everything is there. And, you know, there are different types of equipment So if that particular form does not meet the type of equipment that's being used on your project, then you can always go back to the equipment manufacturer for their recommended calibration procedures and necessary forms that you might use during that process. Okay, in the theory of calibration, you got to know that the mixed components are based on the weight of the dry aggregate. So everything is based on that. Application rates, proportioning of the mix, and the whole ball of wax. So therefore, corrections for moisture in the aggregate are necessary. Setting the application equipment feed rates of emulsified asphalt, aggregate, mineral filler, water, and additives is critical to the success of the application of the treatment itself. The component material output factors identified or determined during the calibration process will not only assist the contractor and agency in quantifying daily material usage, but it will aid in the verification of application rates as well. And long-term performance is always tied to a good and proper application rate. Okay, slurry surfacing equipment does not mix materials in batches. It's a continuous feed of individual component materials, which again are aggregate, emulsified asphalt, mineral filler, water, and additives to the front of the pug mill, which is the mixing chamber. And after being mixed in the chamber, it releases a homogeneous mixture of all these components in a continuous fashion, delivered to the back of the pug mill and into the spreader box. Here you see a schematic of a slurry and microsurfacing machine. You can see the aggregate hopper right here. You can see the aggregate gate. We'll talk about it in detail in just a minute. You've got a mineral filler. You've got the induction of water right here. As the conveyor turns, the aggregate goes through the gate. The Portland cement or mineral filler is dropped on top of that conveyor of aggregate. As it drops into the mixture, it's pre-wetted. Excuse me. It's mixed thoroughly before being introduced to the emulsified asphalt about a third of the way into the mixer. Again, everything's mixed thoroughly. It's pushed out the diverter on the back end into the spreader box. The machine pulls the box, in this case, from right to left, leaving a new slurry seal or microsurfacing overlay behind the equipment. That's kind of a Reader's Digest version of how that equipment works. Now, ultimately speaking, you know, to measure is to know. If we don't do the calibration, we don't know. We're taking enormous chances with our proportioning, and in doing so, we're leaving ourselves vulnerable for potential failure or non-performance. So let's talk about some of the items that are necessary for calibration. First of all, you need a copy of the approved mix design. You need calibration forms. And again, I mentioned that they're available in the design and inspector's manual and or from the equipment manufacturer themselves. Contractor typically has those pretty handy. If an agency wants them, they're pretty easy to get to. You need the component materials on the job, which is the aggregate, the emulsion, and the mineral filler. We need to know what the moisture content of that aggregate is. And more than one time in my career, I've run into situations where you need to find out who's actually responsible for that. Is the DOT responsible for coming up with that moisture content, or is the contractor responsible for doing that? Either way, it is important that we have an accurate moisture content going into this. I tend to like agencies to do that so they are comfortable with that factor rather than letting the contractor doing it and maybe not that they would be unscrupulous, but maybe not cook the aggregate down far enough and get all the moisture out of it and come up with something that may not be as accurate of a test being done out in the field on a tailgate as what might be done in the little local district or regional lab that may be close by. So it's important to know who's going to do that. But either way, it has to be done. You need a certified platform scale or a truck scale. As you can see on the right, truck scales are fine, so are the platform scales that you see down in the bottom right-hand corner. One thing to note, truck scales generally have a 20-pound increment to them. So that's important. The platform scale here generally is a 1-pound increment. So tends to be a little more precise, in my opinion, than a truck scale. If you use a truck scale, you just really need to run more materials out during your calibration process so you get a better and more accurate average. It's not as critical with the platform scale, okay? You need a small postage scale for your mineral filler calibration. And you need containers for component materials. If you're going to do the emulsion, you may want to catch it in a 55-gallon drum. If you're catching your mineral filler, you may catch it in a 1-gallon bucket or a 1-gallon Ziploc bag or things of that nature. But either way, you have to have containers for that. And for your aggregate, we actually do a couple of things. We build a big, I guess you'd call it a big receptacle that you can run the rock in, and you can lift it up with a skid loader and put it on the platform scale. Works very well. You're also going to need a calculator, and you're going to need a tape measure. Okay? So, mix design. At this point, there's no reason to get into the performance data that is included with every mix design, because now we're on the job. All of that stuff's been well vetted by both the laboratory, the contractor who submits it, and the agency who approves it. So really, the gentlemen in the field, the project managers or superintendents, at this point, they're really interested in the proportioning. And that's what you find in the job mix formula. You see the red circles here where it shows a job mix formula at 0.5% Portland cement is the optimum content, and 14% on the emulsified asphalt. Now that's at a 62.5 residual asphalt content in your emulsion. We talked about the leeway or the wiggle room that mix designs sometimes have in them here. You see that it will allow you to go down to 13% emulsion and still get adequate performance, and it will let you go as high as 15% and still get great performance as well. Same on the cement. I've never seen one really actually go down to 0%, but a quarter I've seen before, but it does allow you to go up to 1% from a half. So it does give you a little bit of room to where you can optimize those proportions during the test trip and on the project. So this is what they're going to look at when they start their calibration to know what the desired percentages are on the material that they're going to, on the mix that they're going to be producing. Okay, let's hit a polling question here as we move, before we move forward. So which of the following is not contained in the mix design? And I probably didn't cover this very well, but A, the optimum emulsion content, the application rate, the aggregate gradation and sand equivalency, or the optimum mineral filler content. We'll give everybody a few minutes to answer that question before we move along. Well, it kind of looks like everybody's knocking it out of the park here, so that's very good. It's the application rate. You know, application rate is a component of many things, but the two most influential factors are the size of the aggregate in the mix and the surface condition of the pavement that you're going over. There are other things that affect that, but those are the two biggest things, and that's something that is generally not spelled out in the mix design. So, moving forward. Okay, I think I might have got too far here. Well, I'm not for sure. I'm not locked up, Jason. Yes, we try to get these, okay. The calibration air counters. On a lot of equipment today, you can either have air counters or electronic style counters. but it's important to know that for this calibration procedure that we're going to walk through today, we use the rock counter for both calibrating the rock and the emulsion. And in most cases, not all cases, but in most cases, the rock delivery and emulsion delivery are tied together through a jack shaft. So once you calibrate them and get them set like you want, you can increase production without altering your actual percentages of each component material. Okay, another thing that we've seen probably for the last decade or more on equipment is the computer monitors. We prefer to have both on our equipment. It's if one goes out, you've got a fail-safe that'll help you out. During the calibration process, you can actually enter the weights into this monitor, and it will tell you your gate setting and how many pounds per count, and it will factor the moisture out of it, and it will give you real-time application rates, provided that you put the actual box width, the width of the lane that you're laying, into the monitor itself. It's a valuable tool that really is essential to helping our guys dial in on those desired application rates. And again, it's nice to have a backup. If the monitor goes out for some reason, you have the air counters. If the air counters are having difficulties, you have the monitor. So it's a very desirable thing to have a backup. But these are the units or the metering devices that we use and put our factors into after we've calibrated. Let's talk about emulsion calibration. It can vary depending upon the type of emulsion pump that you use. And there are really a couple different kinds. There's a constant displacement pump, or there's a variable speed constant displacement pump. Now, this is not all that's available, but it's probably more typical on the majority of equipment that's out there applying these treatments right now. If you look at the gray pump here in this picture, it is a constant displacement pump, which means it pumps the same amount of emulsion every time it turns. So it's constant. Now, this black pump, it actually is the same way. It pumps the same amount all the time unless you move this dial here. This dial here that you move actually moves a plate which changes the tolerances within that pump that can either have higher outputs or lower outputs. Now, the only thing I want to say for this is, and these are fine, these are great pumps. If you use this style of pump, or that's what the equipment has, you want to make sure that the setting that was on this dial the day you did the calibration, you want to make sure it's locked into place, and check it occasionally to make sure it hasn't vibrated out of its original position, which could affect that flow of emulsion. That's the only thing. This pump, not really much to check. It's going to pump the same all the time, no matter what. There's no mechanical dial on this or adjustment that can vibrate out of place. So for this exercise, what we're going to do is we're going to use probably the most common pump, which is the constant displacement pump without the adjustment factor. You can see here just an example of what this process of calibrating emulsion may look like. You've got the machine on the right-hand side of the picture. You've got an actual nurse truck with about a 600-gallon tank over on the other side there, sitting on a platform scale. And when they start the emulsion calibration, the first thing they do is they pump enough material to fill the hose, and also make sure that you're getting a little bit of material into that tank. You want to see a weight change on this machine before you actually start your 3 test runs. So again, this is just what it looks like. Okay, so we're going to run 3 different samples or test runs on the emulsion pump and do an average of it. You can see here that this particular nurse truck that was on that scale, its empty weight was 56,940 pounds, okay? We started the machine pumping asphalt. We ran 425 counts on that air counter through that machine and through that hose, and our ending weight of that truck was 58,640 pounds. So totaling 1,700 pounds of emulsion was pumped out of that machine and into that nurse truck, and 425 counts were on that counter. If you divide the 1,700 by the 425, you come up with 4 pounds of emulsion per revolution count on that counter. Okay? That's very important. Well, we do that 3 times, and you can see we've done it 3 times here. We got a 4.0, 4.1, 4.0. That averages out to a 4.0. They rounded that down. But that's as accurate as you can get, and that's what I'm talking about when I talk about constant displacement pumps. For every count, I don't care if you've got 1,000 counts or 20,000 counts, it's going to be putting out right at 4 pounds per count. So you can quantify the material usage, and you can use it also to verify application rates and things of that nature out in the field. Okay, cement calibration. So we're going to do it separately. We're going to do it with the aggregate belt turning as well. You can see in the left-hand picture, you got a little 1-gallon bucket sitting on a postage scale. You need to weigh that bucket first, get its tare weight, and then you need to run your sample, as you can see I'm doing in the middle picture, and then you need to reweigh that cement container with the cement in it, subtract the container weight out of it, and come up with your figures. Okay, let's take a look at what the mineral filler calibration looks like. We started with a 1-pound bucket. We ran 20 counts on the cement feeder, or on the cement counter. Our total weight at the end was 6 pounds, which means we had a net weight of 5 pounds of Portland cement ran through the machine. And we take the 5 pounds divided by 20 counts, and we're looking at a 0.25 pounds of Portland cement per count on the cement feeder. Okay, 3 times. You got to do 3 on every calibration component material, and when we get to aggregate, I'll explain that even farther. But you can see they ran all 3 of them. They're extremely consistent, and the average is a 0.25 overall for material for pounds per count on the mineral filler. Now, when it talks to the aggregate gate, and this is extremely important, with a constant displacement pump, the only way that we can change our emulsion percentage is by raising or lowering this aggregate gate. The lower the gate, the higher emulsion percentage. The higher the gate, the lower the percentage of emulsion. So that's how we control our emulsion percentage to the aggregate, is by raising and lowering that gate. Okay? The aggregate gate height should be set with a loaded conveyor belt, which means it needs to be full of rock, and it needs to be done with a tape measure to ensure exact height. Now, it's important, you can see here that that he's checking it with the tape measure, and he's got a good deal, but you can see that the belt is not full of rock here. He's brushed all of that rock out of the way so that he can get a good measurement. So once he gets that gate set, for instance, say this is a 3-inch gate setting, once he gets done, he needs to charge that belt with rock, which means he needs to run that conveyor belt where that aggregate is at its full height all the way out to the end of the conveyor belt. If not, it will influence your calibration numbers in a negative way because that part of the belt is not full. And that's a pretty good bit of rock if you think about it. That's probably 18 inches or so of 3-inch thickness of aggregate, probably 24 inches wide. That's a good bit of weight. So you want to make sure that you charge it at the beginning and after each gate setting change. Okay. Continuing on with aggregate calibration, after setting the aggregate to the desired opening of rock, run a small amount through the mixer to charge the belt. Not only does it charge the belt, it goes through the pug mill, and any voids and things of that nature that may be in that pug mill that can hold the aggregate, you fill them during that process. So you don't want to you don't want to not do this step is what I'm getting at here. It's important that you do it because it will negatively influence it if you don't fill those pug mill voids up with your first run of the aggregate. Again, you want to weigh the truck or the empty container that will hold the material output. You want to run the desired amount of material onto the ground or into the container, and then you want to reweigh everything. So with aggregate, we always do 3 gate settings. And in this particular example, we do a 3-inch gate setting, a 4-inch gate setting, and a 5-inch gate setting. And at each gate setting, we run 3 samples. And we do that so we can get a good average that when we plot our chart, we're very comfortable with our numbers. And I know the numbers are a little bit small, but what you see here is they ran 50 counts out, about 1,300 pounds each time. They factored in 5% moisture. So they've run 3 runs. They got a 26.0, 26.2, and a 26.4. Those averaged out to 26.2. You divide that out by 1.05, which is the decimal equivalent of your moisture content at 5%, and it tells you that you get 25 pounds of dry aggregate per count. Okay, that's important. So you mark that down, and at that point, you switch your gate to 3 inches. You recharge the belt again to make sure that you've got a full 3-inch thickness of aggregate out to the end of your belt, and you run 3 rounds of samples again. And again, we'll just go straight to the average. I'm hard time reading, that's pretty small. I think it's about 38 divided by 1.05, and it gives you a 36.2 pounds of dry rock per count on average. Okay? We go to 4-inch, again, switch it to 4 inches, charge the belt, do 3 runs. We come right back and take out the moisture, and now we've determined that at 5-inch gate setting, we're averaging 47.4 pounds of dry aggregate per count. Okay, that's great information. Those are the factors we're looking for. What do we do with them? Okay, here's where we plot our chart or our graph. We've got the average dry aggregate pounds per count runs up the left side, and we've got gate setting in inches here. Remember, the gate's the only way that we influence the proportioning of the materials. So we were 25 pounds of dry aggregate at 3 inches. We come up the left side until we hit 25, come across, we make our mark. We do the same thing at 3 inches at 36.2. We make our mark, and 47.4 we make our mark. And if they don't make a good straight line like this, then something's not exactly right, and you may need to go back and revisit one of those gate settings to make sure that you can get a good straight line as seen in this example here. That shows you that incrementally as you raise the gate up, things are doing just like they're supposed to. The machine's performing extremely well in this example. Okay, so now we're going to do a summary of our calibration, and this is kind of a 2-phase deal here, because you've got to mark down your emulsion pounds per count, which is 4, if you'll remember from our emulsion calibration. Okay, then we need to look at our certificate of analysis, and we want to find out what our residual asphalt content is. And you can see here we got a 64.5 residual AC content in our emulsion, and from the mix design, it shows that our residual asphalt content should be about a 7.7 residue with that type of emulsion being delivered. Now, that also equates back out to 12% emulsified asphalt. So there's 2 different ways, and we've got both on this form here. So if you take the pounds of emulsion that you're getting per count, for every count on that counter, you're getting 4 pounds of emulsion. You multiply it times 0.645, which is the decimal equivalent of your residual asphalt content, and then you divide it by the desired residual content in your proportioning of a decimal equivalent of a 7.7%. It tells you that you need 33.5 pounds of aggregate per count to achieve that 7.7% residual binder in your mix. Okay, and I'll show you here in just a minute when we go to the next graph, that's going to put us at a 3.75 inch gate setting, okay? You can do the same thing with emulsion, and some people do that. You got 4 pounds of a count and basically 12%. You divide the 4 by 0.19, and 119 in this case would be 0.12, and it also gives you 33.6 pounds. So just a tenth of a pound off, but very close, and that also will run us to a 3.75 inch gate setting. So numbers are basically identical. That's what we want in this process. 2 different ways to get to the same answer is what I'm trying to illustrate. Okay, so we go back to our aggregate graph, and this is how we determine our gate setting. Remember, we needed 33.5 pounds of dry rock per count to achieve the 7.7 residue or the 12% AE, which is asphalt emulsion. So we come up our pounds of aggregate per count, and we come all the way up until we hit 33.5. We come across until we hit the line. We drop straight back down to what our gate setting is, and it tells us we're looking at a 3.75 inch gate setting. Okay? Pretty simple way to determine your gate setting. And I forgot I animated those things. Okay, so we've got our gate setting. We know what our emulsion's doing. Now we've got to go back and do a summary worksheet on our mineral filler to make sure that we're going to achieve that 1% cement that we're looking for in this design. Okay, to do that, we've got to know what the output of the machine is. We know because we just finished and set our gate that we're getting 33.5 pounds of aggregate per count on those metering devices. For every 1 count on the metering devices, you get 33.5 pounds, okay? We need to know how many pounds of aggregate this machine is running out per minute. So we have to double check and see how many counts we're getting on that counter every 1 minute to determine our output. So what we've done is we've timed it, and we've got 105 counts in a minute, okay? So we're going to take that 33.5 pounds of aggregate per count. We're going to multiply it by the 105 counts per minute, and it tells us that our aggregate output per minute of dry aggregate is 3,517.5 pounds, okay? So that's a lot in a minute. We're mixing a lot as we're going down the road, okay? The percent of mineral filler that's desired from the job mix formula, 1%. So we're going to go right back to the pounds of material per minute, which is 3517.5. We're going to multiply it times the 0.01, the decimal equivalent of the percentage that we need, which is 1%. And it tells us that we need 35.2 pounds of mineral filler every 1 minute to achieve that 1% cement, okay? So we go back to our mineral filler worksheet, and we know that we had 0.25 pounds of mineral filler for every count on that mineral filler counter. So we take the amount we need per minute, 35.2, we divide it by 0.25 pounds per count, and it tells us we need 141 counts per minute to achieve 1% cement. These are the numbers that are important again. And what I have typically done in the past is I will take, just to make it a little quicker where you don't have to wait so long, I will take that 141 counts per minute, divide it by 4, and that'll tell me how many counts I need every 15 seconds. So you can kind of set your machine, then you can go back and double check it, run in a minute, and make sure you're where you need to be. So, another polling question. Calibrating the application equipment and monitoring proper feed rates of the material components of the mix are necessary to. Oh man, 100%. You guys are strong. Great. Okay. Still doing very good. Everybody's on board there. And question number 2. All right, good deal. All right, Jason, let's move along. Looks like everybody's got it figured out. Okay, now that we've successfully calibrated, the first thing that contractor is going to do, he's got the machine set up the way he needs it. He's going to back up over to an area in the stockpile, and he's going to make some trial mixes and make sure that he's got his aggregate or his water set properly, additive if necessary, and then he's going to get ready and go out and do a test strip, which in our opinion should be performed on the actual project site. You can see on the left crew performing the test strip there. Everything's going great. And Jason, if you could play this video, it should give everybody an idea of what a test strip can and should look like. Okay, we don't have any sound here, but you can see you got great uniform surface texture. Everything looks good. Machine's running great. Everything's alignment is perfect. Good, consistent application. And we'll talk about the way we're going to evaluate this test strip here in just a second. But just an idea of what a test strip should look like. Partner. Okay, Jason, if you want to cancel the rest of the last few seconds, we'll move on. Okay, now, the idea behind test strips are to assure that adequate workmanship, aesthetics, and cure time of the mixture is achievable when applied with the personnel, equipment, and materials intended for use during execution of the project. They should be performed in similar conditions as those expected during actual application. If it's a daytime project, the test strip needs to be performed during the day. If it's a nighttime project, the test strip really needs to be performed at night. And of course, if handwork is performed during the test strip, which typically isn't the case, it should have a uniform application rate and surface texture that sufficiently matches that applied by the spreader box. Well, Jason, I think we may have froze up again. Okay, test strip evaluation. How are we going to look at this test strip to determine whether it's acceptable or not? Some of the things we want to evaluate is proportion optimization. Again, we've got that little bit of wiggle room in our job mix formula. Is there changes that are necessary? Do we need to drop that cement down, give us a little more work time before it's in place? Do we need to increase it to make the mix a little bit tougher? Is our application rate proper? Do we have it where we want it? Do we need to make an adjustment? Do we have good surface textures, uniform? Is the equipment in good shape, or is it leaking hydraulic fluid or aggregate from the conveyor belts? We want to make sure that we're not shooting ourselves in the foot by having some equipment that's not in the best of condition out there. Do we have an adequate workforce that's capable of handling all the processes that need to be attended to while doing the actual work? Is the cure time good? You know, is the product setting up like we want it to? Is it breaking and curing in a timely fashion? Is the workmanship acceptable? You know, if they had to do a little handwork, what's it look like? And a lot of people don't put a lot of faith in the alignment or a lot of gravity in the alignment, but you got to pull straight lines. We're very capable of doing so, and it's easily done if you take the proper steps. And those are the things that you want to look for when you're evaluating the test strip. Okay, if the test strip doesn't go so well and it's not accepted, you got to kind of go back to the drawing board and identify the areas where improvement is necessary. You know, where did they have the incorrect rubber in the box and it wasn't producing the uniformity that you wanted? Could they not get the application rate because they had too stiff of a rubber in there? Were the edge lines wavy and not straight? We need, that's the time to identify those areas and make the steps to improve them. Keep making adjustments and perform the test strip again and repeat as necessary until successful. Doesn't happen a lot, but that's the whole idea behind the test strip, is to work out any potential bugs or kinks that you may have prior to getting out and going into full-scale production. So that's what we got to do if the test strip's not accepted. I think I may have skipped one there. Okay, another polling question. Break and cure times are the only concerns you should consider when evaluating the test strip. Everybody's got that one. Next question. If the work on the project is to be performed during daylight hours, the test strip should be performed during nighttime hours. Okay. These questions are far too easy. All right, Jason, let's move on to the next one. Okay, some more considerations. Or another polling question here. Consideration for proper test strip evaluation should include and the answer to that is going to be all of the answers apply. Okay, let's talk about yield checks. They're going to be very important, not only during your test strip evaluation, but during the project itself. You need to do several of these checks in a random nature throughout the day, and it's a pretty simple process. We have all the factors from our calibration, and for instance, if we take a 1,000-foot test strip area at 12 foot wide divided by 9 tells us we've got 1,333 square yards, okay? We start our counters, our metering devices, off at 0. We run the 1,000-foot test strip, and at the end, we have 796 counts on the aggregate counter, okay? We'll come right back up here and we'll say 796 times the 33.5 pounds of dry aggregate per count that we determined during calibration. It tells us that we ran out 26,666 pounds of dry aggregate, okay? Okay, we take that 26,666 pounds of dry aggregate, divide it by the square yards of 1,333, and it tells us that we've got 20 pounds of dry aggregate per square yard. Very simple mathematics, but it's got to be done. The monitor's nice to rely on, but spot checks off the air counter are simple, they're quick, and it just verifies that we're that the contractor's placing, the amount of material that is specified in the job. Okay, so if the test strip's accepted, what do? We go to work. Is exactly what we do. And typically speaking, test strip placement, evaluation, and acceptance generally take place on the same day and within a short period of time. You know, a lot of times we find that an hour is about all you need if the material's curing properly, everything looks good, equipment's working great. The agency can tell whether the contractor is in a condition, whether they can go to work or not. So that's typically the way we see it. And if the test strip goes well, then go immediately to work. Okay, we got a little bit of time. We'll try to go through this troubleshooting pretty quick. That was calibration and test strips. Extremely important. Prior to any job startup, you need to do them both. Now, in the design and inspection manual, you see we've got several categories of troubleshooting listed in the index. In fact, we've almost got the entire alphabet covered. We obviously do not have time to cover all of those topics here, so I just cherry-picked a few. But before we start, the thing about troubleshooting, you know, there's some steps to it. You know, you got step one, you just need to identify the problem. We're not going to get into all the information I have here, but you just need to know what it is. Is material setting up too fast? Is it not curing? You know, is it not mixing properly? Establish what the product is or problem is. Establish a theory of probable cause. What are the items that could be creating that issue? Got to create an action plan. How you propose to do a process of elimination to determine what the cause of the problem is. You need to implement that plan, and then once doing so, everybody assumes that the problem has been solved, and at the end we need to document those findings so we know the next time that situation happens, the process of elimination that we need to go through to verify that information. So those are just your typical troubleshooting items that you want to consider, and very prudent to follow those 6 steps. So here's one of the items I picked out of the manual, and it's about non-uniform color. And the condition is when the finished surface may exhibit color variations. They may be discernible, may not be discernible until the next day or more. They will usually disappear as the slurry surfacing or microsurfacing is exposed to traffic and elevated temperatures. And these issues are predominantly aesthetic or cosmetic and will not affect long-term performance. If the color does not come back, there's a pretty good way to remedy this situation, and that's the fog seal with a very light fog seal, that pavement to give it good uniformity of color. But again, typically not a long-term performance issue. But there's a couple of things that could cause it. It could be an equipment issue, which it may not be accurately calibrated, or there could be a mechanical issue affecting the proportions. Well, we need to go back and verify that kind of our calibration is still good and all of those component material delivery systems are in good working order. And then once we've done that, we have to determine if the machine's running great, then there must be another cause. Could it be some environmental conditions? Did we see rain or extremely cool temperatures prior to the equipment getting a full cure? Or was the humidity extremely high? We have to, like I said, process of elimination on troubleshooting, just like we do on just about everything. Okay, here's an example. On the left, you see a microsurfacing that was put down, and prior to full cure, it received a little rain, and it just looks horrendous. You see a little bit of fines and things of that nature that are discolored. Doesn't look very acceptable. But with a little heat and a little traffic, you can see the end result after 2 weeks. So it's one of those things that agencies that aren't that familiar with it can be really concerned when they see that picture on the left. But if you can talk them into waiting just a little while and giving it several days and some warm temperatures and traffic, what you see on the right is what you may get as an end result. So another potential cause of this is the emulsified asphalt. If it's got a high dosage of emulsifier, or if the contractor using a lot of additive to get the material down, it can create a little bit of slower cure times that may contribute to this, or if somebody's using an extreme amount of water in their mix and floating some of these materials, that could have an effect on it as well. So those are the three things that could potentially create this non-uniform color. Now, let's talk about premature breaking of the mix. If the mix is setting up, coming out of the pug mill or in the spreader box before you can get it applied properly, there's a lot of things that it could be. It could be inaccurate calibration again. It could be incorrect loading of the mineral filler. It could be the formulation for the emulsified asphalt has changed or is incorrect. It can be the use of non-potable water. Maybe you got a load of hot emulsion. Maybe you're not using a spreader box with augers, which we recommend on every job, slurry or micro. Maybe you need to put a little additive in it. Did the aggregate supplier send you freshly crushed material, which tends to be a little more reactive in that state rather than material that has had a while to weather and cure? Changes in gradation or sand equivalency. We need to check those through your QA/QC program. And has the reactivity of the aggregate fines changed, or has it just gotten really hot overnight? If you're laying 80 degrees one day, the next day it's 95 to 105, that could have a direct effect on the premature breaking of the material. Of course, prevention, we want to verify that calibration. We want to confirm the compliance of the materials, make sure that everything's still in spec. We want to make sure that the emulsion's properly formulated. We want to make sure that our water source is good. We want to, maintain constant movement in the slurry box, which is back down to the augers that I mentioned a minute ago. And we want to make sure that the operator knows that he can put some chemical additive in there to buy us a little more work time with that material so we can get it in place in a proper fashion. And then we also want to work closely with our aggregate suppliers to make sure that they're sending us well-seasoned materials rather than stuff directly off the crusher belt. And then if it's too hot in the middle of the day or the late part of the day, we want to try to get an earlier start at it and work a little earlier in the day. Troubleshooting, next condition, poorly constructed edge lines. You can see here on the right and the left picture, neither one of those are, I would consider, acceptable workmanship or anything close to it. And that's when the slurry surfacing edge lines do not appear uniform and are not properly aligned with the shoulder or curb line. Perfect example of what not to do here. Okay, what are the possible causes? Crew having difficulty following the edge line or curb line. So maybe you don't have a very good line driver that can put that spreader box where it needs to go. There are ways and drag chains and pilot lines and things that you can do to alleviate that issue. Or the mixture contains an excessive amount of liquid and has some free-flowing liquids in it that makes it very difficult to produce a good straight line like you see in the picture here on the right. Prevention, want to make sure everything's in compliance. We want to operate the spreader box and align the application equipment so the edge does not vary more than 3 inches on a 100-foot straight section or in a 100-foot arc or curved section. Just got to maintain that accurate equipment calibration, adhere to the job mix formula, and maintain the proper mix consistency necessary to produce straight edge lines. It can be done. It's done every day. You just got to make sure that the contractor's getting it done. Special situations, just as well as the troubleshooting, we cover several topics which we can't go into here. But if you'll get signed up and go get your electronic version of the inspector's manual, you can have all this stuff at your fingertips right on your computer. Okay, cul-de-sacs. Of course, we know everybody knows what a cul-de-sac is, and we know that the equipment that's used to do slurry seal and microservicing is large and maybe not as nimble as smaller equipment may be, but they've always created problems. And when you get into cul-de-sacs, you've got to have a proper method to do it. There's going to be some handwork. The handwork needs to be done properly. It needs to be done little pieces at a time. Don't bite off more than your handwork guys can chew. Make sure it's done right, because the last thing you want to do is finish it and have to come back and address that area again. We want to make sure that if we've got a bunch of cul-de-sacs on the schedule, we talk with our emulsion supplier and have a formula that gives us a little bit more time to handwork that stuff and get it into place and keep it cosmetically appealing, where we have good bonds and performance down the line as well. So, you just have to be prepared. You got to know what kind of job you're going into. And the example you see on the right-hand side here in that picture is just about as good a work as you can get. Okay? Another special situation is protecting special markings and utility castings. We talked about this briefly or at length in part 1. And, although masking special pavement markings was common practice in the past, it is now believed that the ridge created around the stencil creates a ponding problem that promotes pavement deterioration. And the next slide, I think it is, that I'll get more into that. But as far as manholes, water valves, catch basin, drain inlets, 30-pound roof and felt, duct tape, and a chip seal tab are what we found to be very effective in masking those areas off. You can lay right over the top of them. Once the material's cured, you can expose that utility again, and everybody is happy. Now, when we start talking about taping or masking off, say, for instance, the left-hand picture with the snow-plowable pavement marker, that's not good. What we've done is we've created a pond right on the center line, and you can even see some of the deterioration that's taking place in and around the edge of that snow-plowable marker. It's just water standing there. And what I found interesting on this 8-mile-long job, there was not a reflectorized marker glued to any one of those snow-plowable markers. And I revisit this area quite often, and they've still not been put there. So not really much value in doing this. Remove that thing, fill it up with high-performance cold mix, tamp it down, let it be under traffic for a little while, and then after the project's over, come back in and reinstall those treatments. Now over here, we've got an agency that had a thermoplastic crosswalk that they wanted to maintain. And we've seen people ask that we tape off just the thermoplastic marking itself. And that's what, when you do that, you do create a pond. If you tape that off and try to do these asphalt sections in between it, you're going to create a ponding issue. And when it rains, you're going to have standing water. It's not going to be visible to the traffic and so on and so forth. So what the contractor recommended was to just skip that entire area. And pretty acceptable. You still got the crown of the road, water flowing to either side of the road, not really much of a ponding issue. So if you're going to do it, that's a pretty good way to do it. Handwork, it's the only slide I've got on it. It's a huge item, but I just want to point out that it's important to kind of come in and handle some of the handwork before you back up and start pulling the lane. In the old days, they would pull that lane down, they would stop here, they would pick up the spreader box, and they would have material that's been riding along in that spreader box for 100 or so feet, that's already starting the chemical break and cure process, and then you'd have to try to move it over here into the radius, and it just didn't work very well. So come in and do those prior to it. You can see the contractors went beyond the call of duty and kind of marked out the way the line driver is going to follow that line. You can see them coming down into the intersection here. They'll barely overlap the handwork that they did, and you can see them coming out. And it's just a fantastic way to do things. Generally produces a much more acceptable end product. So, keys to success. This is one of my favorite slides in all of my presentations. Proper site selection. You can have the best materials, the best crew, the best equipment, the best oversight in the world, but if you're performing these treatments on a poor site, none of that matters. So that's first and foremost. You've got to have proper site selection to make sure things, the right treatment on the right road at the right time. You've got to have that. You got to have good specifications, which there are good specifications out there. But more importantly, those good specifications need to be enforced. And that really goes back to a familiarity issue. We find a lot of agencies that are not familiar with these thin non-structural surface treatments. They hesitate to enforce things because they're not familiar, and that's not what we want. So continued education is a big deal. We've got to have good specs. You got to have good roadway preparation. You got to have that early patching, crack sealing, curb repairs, and things of that nature that we talked about in part one. Those need to be both early and the final stuff. The final surface prep is extremely important. You got to have proper equipment. You want to match the equipment to the project. You know, if you're doing a bunch of crossovers on a highway out there, a truck-mounted unit is perfect. You know, if you're doing shorter roads, truck mounts are great. If you're doing long stuff and want continuity of mix, continuous machine may be your thing. That's also covered in part one, I think, which is available through a recording. You want a thorough and accurate mix design. We talked about that earlier. Without that, you know, you're shooting in the dark. You're leaving yourself vulnerable for potential failure. You want accurate and thorough equipment calibration. Now, I cannot say it enough times how important that is and how important it is to have agency participation in that. We want good material consistency, and I like to say I like to use materials with a history of past performance. You know, I've been around, you know, Jason said 32 years earlier. That makes me a little younger than what I am because it's actually bumping 36 years now. I think I need to update my bio, but there are aggregate sources and emulsion sources that I have been using for the entire time I've been in this industry, and I'm very familiar and very comfortable with them, and they've got over 3 decades worth of past performance. Very comfortable with those, love to use them when I can, and recommend that. Proper application rates. Not only does a contractor need to apply the proper application rate, the agency needs to specify the proper application rate. And for an agency to determine what that application rate is, they really have to rely on history a little bit. You know, if they're kind of new to the industry, they need to do their due diligence, talk to other agencies that have done the work, kind of know about the size of the aggregate, deal with industry, and industry wants these products to perform. So I think they'll lead you in the right way and give you some proper application rates. You know, you may consider ton and gallon pay items versus square yards. You know, that's the 2 different ways that you can pay for these treatments. You know, ton and gallon, the agency pays for exactly what was installed, and the contractor gets paid for exactly what he installed. Square yards, I see the advantage. The price on bid day is the price that you're going to see at the end of the project unless the agency makes changes. But if you've got a tolerance in there of a couple pounds per square yard, the difference between 18 pounds per square yard and 20 pounds per square yard definitely can have an influence on long-term performance. So also when you do ton and gallon, you kind of encourage contractors to use the optimum asphalt contents rather than skinnying things down to the lowest side of the mix design, which can and definitely will have long-term performance issues. Screen all the aggregates when you can. If you're not out west and dealing with dust abatement issues, screen everything directly in the truck. That will eliminate a ton of drag marks, a ton of handwork, and will definitely provide a better product on the road. Contractor performance, you know, make sure the contractor's got a well-trained workforce, you know, that's well-seasoned and with a great reputation. Everything doesn't have to be low bid. It can be lowest and best. Herbicide treatments, you know, use them when necessary. So our emulsified asphalt seems to make grass grow greener and stronger than most fertilizers that I see. So make sure we get on that as one of the early treatments prior to contractor move in, kill that grass off, let the contractor come in, remove that dead vegetation, and the chances of it coming back and being prolific are limited. We want quality project inspection. You know, a lot of agencies are here today getting up to speed and becoming more familiar with what we do. I applaud you for that. An agency is willing to help at every turn as it comes to that topic. So, but we need it. They are the great, they level the playing field because not all contractors are good at self-policing. And when they're not, that's when we need the agencies to step in and make sure that the bar remains high on the workmanship and the treatments that are installed. Public notification. I'll say it again. An informed public is way better to deal with than an uninformed public. And not only from the agency's perspective, but definitely from the contractor's perspective. We, on our notifications, we put our project manager and project superintendent's phone numbers on it, so those residents can call them directly about scheduling issues or anything that may be of an issue. That way that those concerns can be addressed immediately rather than somebody having to talk to City Hall, 3 or 4 people, then they talk to the contractor, and then by the time they get back to the actual resident, they're a little red-faced and hard to deal with. So notifying the public's a big deal. And then I love the agency-industry relationship. I use the term partnering, not in the legal sense, but I have found that the best projects that we do annually or for my entire career have been when the agency and the contractor work together, you know, to accomplish the same goals. And it can be done, and it's done a lot. There are some that can be a little adversarial, but if you can ever achieve that partnering deal on your projects, I think you'll see the direct result in the quality of the ending project. So that being said, I'll just show you a few pictures of what kind of workmanship you can see when best practices for slurry seal and microsurfacing are utilized. Now this is when everything's going right. The materials are working together, long history of past performance, the crew's great, the equipment's great, the residents were great to deal with. This is what happens when everything is right. And that's what we should strive for. I don't think anybody in this group or any group that I know of would have a problem selling that to any agency. And like one of my favorite comments is good is the enemy of great. And with that, I'll tell you about the resources that you can utilize to help you in your goal to familiarize yourself better with these treatments. Of course, you got FHWA with their website there on preservation. You've got the PPRA, the Pavement Preservation and Recycling Alliance. You've got the International Slurry Surfacing Association, ASHTO, the Resource Accreditation Program. You got the FP2, formerly the Foundation for Pavement Preservation, and then of course roadresource.org, which is a PPRA website where you can go in and learn a little bit more about managing your pavements. We talked about free design and inspection manuals. I want to bring this up. Government membership to ISSA is free of charge, and any government employee of the entity that signs up can sign up through an employee membership as well. And if they do that, they can contact Allie or Ann, and they can get a copy of that new design and inspection manual and have it at their fingertips at all times. And I'm going to pass along a little time to Miss Ann right now, and she can kind of tell you about the next webinar that's coming up, and then I'll close out. Miss Ann?
Yes, and thank you, Tim, for your presentation today. We really appreciate your time and expertise. The next PPRA FHWA webinar will be held on January 27th at 2 p.m. Eastern, and will focus on Asphalt Emulsions 102, Beyond the Basics. We hope to have you join us then. With that, we'll go ahead and pass it back to you, Jason.
Well, Jason, before you, I want to say thank you to everybody that has stayed on through this presentation. Calibration is not a riveting subject, but again, it is uber important as to the outcomes of these treatments. You know, not only with microsurfacing and slurry seal, but knowing what your distributor's putting out on chip seals and fog seals and things of that nature. I can't stress how important those items are to pay particular attention to. So I'll sign off. Thank you for your attention. Thank you for being here. And if you have any questions, there's my card. Give me a contact, and we'll go from there.
Hey, Tim, we did have a few questions if we have a little bit of time. And before we jump on to it, I ask everybody to please get a chance in the middle of the screen, use your arrows to go through the evaluations, as well as in the file share. The presentation of today's is available as well as what Tim mentioned, past webinars of last year and this year's are available on the other two attachments. I had a question there was about are rubber tire rollers recommended, Tim?
Well, typically, rolling of slurry seals or microsurfacing is only necessary in parking lots or airports. And that's typically because they don't get the rolling type return to traffic situation that you do on highways, residential roads, or whatever. So typically only on those two type settings. Now, if you've got an area where you're experiencing a lot of power steering burns, or have in the past, you might consider it, but mostly airports and parking lots.
Okay, Tim, I had another question. For the field adjustments to increase or reduce curing time, what additives are recommended?
Well, those additives typically come from the emulsion manufacturer and are very similar and or the very same emulsification agents that are used in the emulsions themselves. You know, there's some that, you know, one emulsion manufacturer may use one, a different emulsion manufacturer may use another one. We don't typically see any accelerators as far as additives go. That's typically what the mineral fillers can do. So they're generally retarders. You know, they're additives that if you use a little bit of it can buy you a little bit more working time so you can get the treatment in place before it starts breaking and curing and therefore ensure bond and performance down the line.
Tim had another question. What happens to an unacceptable test strip? Is it just left in place? Is it somehow removed?
If it is part of the project, you can just generally go right over it. You know, they're very thin treatments. Typically, they do not need removed. You know, if something really bad happens and it needs to be removed, then you need to get on it really quick. If you got a skid loader handy, or, you know, if they pulled 10 feet and the material set up in the box and they had to stop, then yeah, you can kind of address that with shovels and brooms and things of that nature. But if it's just a kind of a cosmetic issue, or it has a little drag mark in it here or there, or something like that, typically you just go over that section again.
Thanks, Tim. And I had another on test strip. During the test strip, it was not clear whether there was a gentle spray in the front of the distributor screws and screed. However, most papers use the fine mist. Why is that?
Well, and it's never, and we do believe in that, and that does help with bonding, but it is not a necessity 100% of the time. Sometimes that water spray bar can cause some constructability issues. Most of the time it doesn't, but there are times, especially if you're on a flushing type pavement with a lot of excess asphalt on top of it, that little spray of water can kind of make the microsurfacing or slurry material kind of slide along the material rather than coming out of the spreader box and leaving the thickness and application rate that you need. But now, in a typical setting, it's great. It breaks surface tension. It helps with that, for lack of a better term, a little bit of drain down, so it helps with your bonding, which ultimately, if we don't bond with our thin treatments to the existing pavement, we're not going to perform. We don't have the luxury of 110 pounds, you know, per inch, you know, of thickness of a hot mix. We don't have gravity on our side. We have to bond. So cleanliness, a little bitty light spray of water, again, helps break surface tension. If there's any fine particulates that didn't come up with the sweeping and blowing, kind of settles that down and kind of ensures a bond.
With that, Tim, Gary had a comment, increasing water, additives, and like often results in problems, including non-uniform surfaces and excessive shedding. Would you agree?
Well, as any good technical response requires, you have to start with it depends. You know, it depends on the time of the year, the temperature, the traffic situation, things of that nature. But if, you know, ultimately you want a controllable system. And I didn't mention this earlier, but what we have found probably over the last 7 or 8 years, we try to get some materials delivered in early to the job when practical. Sometimes it's not. We get aggregate samples. We send them to our emulsion supplier. They look at them for, first of all, compliance with the mix design that we've submitted. Are we within our tolerances? And then secondly, we want them to mix those with the emulsion that they intend to provide us on the job to make sure that those break and cure times are going to be adequate for the conditions that we're going to be working in. Now, what that potentially does for us, it prevents any bad things on day one. If they send me a material that is too fast to work with the aggregate I've got, well, next thing you know, I can't work. I've got to clean up a little bit of a mess because we couldn't get it to work. Now I've got to send that material back, and that's the last thing they want to do. So if we take those steps on the front end, we can eliminate a lot of those issues. And again, that's not practical on every job, but we try to do it when it's feasible, which is more often than not. So yeah, you don't want to overload water or emulsion or additive. None of that's good. If that's the case, you find yourself having to do that to apply the material, really need to work it out with the lab, maybe on readjusting that emulsion content and or make sure that that aggregate's in spec. You know, make sure that that sand equivalency number hasn't changed. Make sure that the fine reactivity, the methylene blue factor, hasn't changed. Check with the quarry to make sure that they're not sending you product fresh off the crusher. You know, the energy that it takes to crush that aggregate is absorbed within that stone, and it takes a while for that stuff to, you know, to leach off of that, to bleed off of that, and time and rain and weather and things of that nature happen. So, you know, there's all kinds of things. Again, when you troubleshoot, you got to look back and just do that process of elimination. So you need to check the machine. Is your machine delivering the components like you think it is? So, you know, it's a step-by-step process. But, yeah, overloading with water and additive, never a good thing.
I have one remaining question, Tim. What's the indication for you that you need to tack the surface?
To tack the surface?
Yes.
Concrete, brick, or extremely oxidized. Those would be my three things. I can tell you in all of my career, which is 35 plus years now, we have tacked very little. And some of those instances were on airport runways where pavements tend to dry out and oxidize extremely bad and extremely, you know, in a rapid fashion. And extra asphalt on an airport is never a bad thing. You're not going to hurt yourself there. But bonding, at least for the most part in the South, has never been an issue for us. We don't see delamination issues, and we get good drain down. And again, that may be a good reason to consider paying by ton and gallon rather than square yard. Give that incentive to that contractor to put the asphalt in the mix. And if he does that and he runs a good consistent mix, you're going to get good enough drain down. And I know some don't like that term, but that's what really creates the bond between our products and the original or existing pavement. And if you've got a contractor on an oxidized pavement and you're paying by the square yard, and it was a highly competitive bid, and he's looking at ways, you know, to maybe shave off some costs and become a little more profitable, well, cutting 0.5% asphalt emulsion out of the mix is a surefire way to do that. But what does that do to long-term performance? So I tend to think that there's better ways to do the same thing without having to go to tack coat. Now, there are some areas that tack coat, not a ton of them, and they do it for various reasons, but we just don't see a lot of delamination, and we stick with ISSA's recommendation of concrete, brick, or highly oxidized pavements.
Tim, that concludes today's webinar. I want to say thank you so much for your great presentation, and any final words you would like to say to the audience.
No, I'd just like to say again, thank you very much. And this is just a little snippet of information that is available out there. That FHWA ISSA web-based training is fantastic for people with limited familiarity with these treatments. This webinar series, which is going to continue down the line, there's all kinds of information out there, and just be diligent in your efforts and familiarize yourself with it. And when we all are as familiar with these treatments as most agencies and contractors are with hot mix treatments, guess what? We're probably going to have some better successes down the line, or more successes. So familiarize yourself. Anything ISSA or I can do to assist in that is what we're willing to do. So you've got my email address, my phone number. Don't hesitate to call if you have questions.
Thank you, Tim. And now, Jen, that concludes our webinar for today. Thank you, everybody, and we look forward to next year.
All right. Thanks, everyone.